In this lesson, I will explain to you about empirical rule, which is also known as normal rule. First of all, I will explain to you what is empirical rule and why it is known by normal rule, because in this rule, all the data is distributed normally or equally, or you can say data is distributed in bell shaped. Bell shape means, suppose if we have a mean in the center, suppose this is the mean, right? And so data is equally divided between the left hand side and the right hand side of the mean. And when we make the curve, you will see always the curve is in the form of bell shape. That is why it is called the bell shaped curve or normally distributed curve. So empirical rule applies to a normal, a bell shaped curve, so the results are more accurate than the Chebyshev theorem. We have discussed Chebyshev theorem in the last lesson, because Chebyshev theorem applies to any kind of shape, right? There is not necessary to have the bell shape, any shape. Suppose if the data is distributed like this, or in another form, in the rectangle form or J shape, whatever. That is why in Chebyshev theorem you cannot get the accurate answer, but in the empirical rule, which is called the normal rule, you will get accurate result compared to Chebyshev's theorem, because data is equally divided. It states that within one standard deviation of the mean, both left side and right side, there is about 68% of the data. Now what does it mean? Suppose this is the mean, right? I will draw a line. This is the mean. So your data is equally divided on the right hand side of the mean as well as on the left side of the mean. Mean 68% mean 34% data you will find here. 34% data you will see on the left hand side of the mean. So mean is represented by mu. So here and here we will say mu plus 1 sigma, because this is the right side. Suppose if it is a bar line, on the right hand side you have a positive numbers, on the left hand side you have the negative number. So here is mu minus 1 sigma. So 68%, 34% you will find on the right hand side, 34% data you will see on the left hand side. Data is equally divided if you have one standard deviation of the mean. This is the mean. Within two standard deviation of the mean, both left and right sides, now here and here, so it will be mu minus 2 sigma, here will be mu plus 2 sigma. 95% of the data you will see both side, half here, half here. You will not see that 95% on the right hand side only, or 95% data is distributed on the left hand side. It is equally distributed on the left hand side and the right hand side. Then we will get the curve in the form of a shape. And within three standard deviation means mu plus 3 sigma on the right hand side, mu minus 3 sigma on the left hand side, and 99.7% data is distributed if you have a three standard deviations. I will show you here with the help of example, but here is some more explanation. The percentage of values from the data set that fall within k standard deviation. K means 1, k is 2, k is 3. When k equal to 1, 68% of data is distributed both side of the mean. When k is equal to 2, 95% data is distributed both sides, half here, half here. If you have a k3, then 99.7% data is distributed both sides of the mean, half here, half here. So empirical rule can be broken down into three parts. 68% of the data falls within the first standard deviation from the mean. So this is the mean. And what is the first standard deviation? You can write down this is mu, 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 because this is mean. Mu plus 1 sigma, 1 standard deviation. Mu plus 2 sigma, here mu plus 3 sigma. Similarly, on the left hand side, mu minus 1 sigma, mu minus 2 sigma, and mu minus 3 sigma. This is when you will make the graph. So always you will see it is in the bell shape. That is why it is called the normal distribution. See, this is the mean, and both sides you will see data is equally distributed. This is mean. Here you will see mu plus 1 sigma, and on the left side mu minus 1 sigma. So 68% of your data will lie in this range if you have k is equal to 1. If k is equal to 1 is standard deviation 2, then 95% data lie between this range. If you have k is equal to 3, then 99.7% data lie here, half here, and you will get, always you will see the bell shaped graph. Here I have set the example for you. Suppose average score of SAT in 2007 was 480, and this is the average score. Standard deviation is 30. Distribution was bell shape. So from here you can find out that this is the empirical rule. Data is distributed equally on both sides of the mean. Calculate the boundaries of 68%, 95%, and 99%. Suppose this is the mean, right? This is the mu. So you have to find out how much data is distributed here, and here you have to set the boundaries. 68% means 34% here, 34% here. So what is the, I told you the formula. It is mu plus 1 sigma on the right hand side, mu minus 1 sigma on the left hand side. So mu is 480 plus 1 sigma is this 3 standard deviation. You will get 510. Mu 480 minus 1 sigma 130 is equal to 450. So your range is 450 to 510. If k is equal to 1, 68% data means it ranges from 450 to 510. If you will add these two and divide it by 2, you will get 480. So this is the boundaries. If you have a k is equal to 1 and 68% data will distribute. When k is equal to 2, 95%. 95% means when mu plus 2 sigma, when k is equal to 2. So 480 plus 2 sigma 540, 480 minus 2 sigma 420. So your range is between 420 to 540. If you will add this divided by 2, you will again get 480. Similarly, 99.7 means 3 sigma when k is equal to 3. So 480 plus 3 sigma mu, right? This is 480 mu plus 3 mu here, mu minus 3 sigma. So you will get 390. This is the range. Again, add 390 plus 570 divided by 2, you will get 480. It means data is equally distributed both sides of the mean, and you will get curve like this. And it is also mentioned the distribution was bell shape, empirical rule equally. So in the empirical rule, you will get accurate answer compared to Chebyshev theorem, because in Chebyshev theorem, data is not distributed in the bell shape. It applies to any kind of shape. So you have learned empirical rule in this lesson. If still you have any question, without hesitation, write down in comment section. Please do not forget to subscribe to my channel, Sci My Academy, and thanks for watching.